It is now time to grind. Let us look at question 2 of the November 2025 Exemplar. This question will be based on organic chemistry. Now, when we deal with chemistry questions, what we do is that we apply the problem-solving strategy, which we call ICAN. And this says I can. In other words, it allows you to be able to solve any problem in chemistry. The I stands for interpretation. That means before you do any question, read through it and interpret that question. The C stands for the classification of the problem. This implies that after reading the question, analyzing it, and understanding it, you then link it to the specific sections of organic chemistry in this case, or whatever topic you are dealing with. After linking this question, you then are ready to answer the questions. The A will stand for answer. And always look at your answer, navigate your answer to see if your answer makes sense. Now, I will apply this problem-solving strategy as we go along. The first thing would be asked to read the question. The question starts by saying that the letters A to H in the table below represents 8 organic compounds. So we are given 8 organic compounds through the letters A to H, and they're here in this table. If we look at compound A and B, we can see that we are given structural formulae. And if you go to C and D, we are actually given the IUPAC name, or the chemical name of these organic compounds. And when we look at E and F, we are actually given the condensed structural formulae. Then with G and C, we are given the molecular formulae. This is just going to be my interpretation. I'm not going to go in depth interpreting this because there could be a lot of things and I could waste time. So at least if I can see what structures I'm given and what's happening, that will prepare me in terms of answering my questions. Now, obviously, when I look at this table, I can see that this question can then be classified as a question that requires the basics of organic chemistry. I could be asked questions such as naming. I could be asked to define some of the terms that we know, like structural formula, isomer, homologous series, and all those basic terms that we know at the beginning. And I could get questions around reactions, because some of these compounds may react with others to form, other compounds. And so now, because I can see how this question is structured and classify this question, I'm ready to go answer it. Now, with answering, we directly go to our questions and attempt to answer them. Question 2.1 says to us that define the term homologous series. We expected such a question from the structure of the question, the way it's given, and how we interpreted this question. So we are on question 2, and we are looking at 2.1. A homologous series really is a class of organic compounds or organic molecules. So this is a group of organic molecules in which one member differs from the next member with a methyl group. That is to say that we have here CH3. So we're saying a homologous series is a class of organic compounds in which one member differs from the next with a methyl group. That is, they differ with the CH3. So I'm rereading my question again here to make sure that my spelling error and everything is correct. And by doing so, of course, I'll get the 2 marks. So I've answered the question here and navigated the problem by going through what I've written, reading it and making sure that it makes sense. So that's basically the strategy that we use to answer questions. Now note that there are other definitions that they can be accepted and guarantee you a mark. One may define homologous series as a series of organic compounds that can be described by the same general formula. You'll also get a mark. And there are other ways, of course. Now we'll go to the next question, which is 2.2. They say write down, and then we have a series of questions. The first one says here, the general formula for the homologous series to which the compound H belongs. Now, if we look at quickly at this compound, it seems to me that it's a compound that has only single bonds. I suspect that it is an alkane. So that is to say, if I take the formula of an alkane and say here I have Cn H2n plus 2, and I put a 6, we say n is equals to a 6. I'm going to have a Cn, then I'm going to have a 2 times a 6 here, which is a 12, plus a 2, I get a 14. Then that means this molecule here is an alkane. It's a homologous series of the alkanes. So that means our general formula will be this formula here. Now I'm going to then write that formula to say I have a Cn H2n plus the 2. And really this is only for 1 mark. So again, you can just go through it and look at the fact that you have written everything correct. You didn't write the negative there, or maybe you omitted the 2 elsewhere. Now we go to the next question, which is 2.2.2. And it says here that write down the structural formula of compound G. Now when we look at compound G here, we are given C3H6O. Now if I were to write the structural formula of this, the first thing that I'm going to do is to write my carbons there, the 3 carbons that I have. Then I'm going to populate these carbons with a hydrogen. And I must only have 6 hydrogens here. 1, 2, 3, 4, 5. So maybe the last one I'll put it here. And you'll notice that now I have an oxygen here. And we have 2 bonds here. So this would mean that this bond has to be a double bond, and I'll have the oxygen there. And this actually becomes the aldehydes, because the best way in which I remember the aldehydes, really just to share with you, is that I say that all the days we do chores. All the days we do chores. At home, we always do chores. This sounds to me more like aldehydes. And you will always see aldehydes with CHO, the chore there. So this part goes with the chores. And this whole statement, all this, it sounds more like aldehydes. So that's how I remember them. So I can see here that I have the CHO. So that is the functional group of the aldehydes. That is just a technique you can use for you to remember the functional group of the aldehydes. And of course, I have to mention that with this structure, you could write the structure in such a way that the functional group is on this side. You will still get the correct answer. So this was with 2 marks. So they'll mark the functional group and also that your structure is correct. Now we go to the next question, 2.2.3, which says to us that write down the structural formula of the functional group, very important, of compound D. Now if we look at compound D, we are told here that it is a keton. I understand that there's some words here, methyl, ethyl, keton. The fact that it's a keton, already I should then write down the functional group of a keton. I don't even have to worry about naming or understanding the other words that are there. So when we look at 2.2.3, we know that a ketone is given by C, a double bond, and we're going to have the other bonds on the carbon, because remember, carbon has to have 4 bonds because it has 4 valence electrons. Now, another way in which one can write this really is to say you have a C here, and of course we have the O in the double bond, then we have another C here. That is also acceptable. Some people would actually like to write this in such a way that we have a C, then we say it bonds to R, so the R could be any other organic molecules, like that will have the C here as I've written them there, and of course we have a double bond here. All these formulae that I've written down here, they will give you 1 mark. Any one that you choose or that you have memorized and know, they will give you 1 mark. I sometimes also remember a ketone by the letter CO. The C usually sounds like a K and we have an O here. So when I see CO, this part here, which is a double bond, I know that that is my ketone. That's another way in which one can use to memorize or remember a ketone. Now we go to a set of other questions in 2.3, which says to us here that write down the letter that represents each of the following. So here we only write the letter. Under 2.3.1, we are requested to write the letter for an alcohol. So we're looking for an alcohol. We know that an alcohol should have the OH group or the hydroxyl group, if you like. And usually it ends, if you write the name, it ends with nol at the end, or anol, if you like. Now, if you look at all these structures, there is none of them that has an HO or anol except for C, where we have ethanol. So that should be our alcohol. So C would be the correct answer for this. And this question is really out of 1 mark. Now the second thing that we're requested to write, the second letter of a compound that we're requested to write here, is a compound with the carboxyl group. Remember that the carboxyl group falls under the carboxylic acids. And the carboxylic acids, I usually say they are cool. So a way to remember them here, again, let me share with you another way in which you can remember the carboxylic acid. I say here, carboxylic acids are cool. The cool here goes with COOH. So this is what you should see in your molecular formula or your structure, the COOH. And of course, the carboxylic acids are cool because they have real-life applications in biology and also industrial processes. So I found them to be cool. Now, if we look at our structures here, you would see that the structure that has a cool, that is cool, is this structure here. We do have that COOH. You know, the C here, the O, and the H. So this molecule here must be cool, and it is a carboxylic acid. So it falls under the carboxyl group. So the letter here, the answer for this would then be A. And again, this would really be also for 1 mark. Now, if we go to the next question here, we are also requested to find a compound with the IUPAC name butanone. Now, obviously, when you have a name that ends with anon, we know that that molecule must be a ketone. And in fact, we already spoke about this molecule when we were looking at D. It was our ketone, because if you look at the other molecules here, they don't have the functional group of a ketone except the D there. And actually, if we were to rewrite or to draw the structure of D, perhaps we can be able to see where the name comes from. Now here I have a methyl. That would mean on this side of things, I'm going to have CH3. Remember, a methyl is an alkyl group. It only has one carbon and 3 hydrogens. And this will bond to our ketone. Which also then on this other side, it will bond to the ethyl group. So we started with our methyl group and then we are looking at the ethyl group. Ethyl group will be made up of 2 carbon atoms, where I'm going to have the first one to be CH2 and the last one to be CH3. Now, if you look at this molecule, you can see that it has 1, 2, 3, 4 carbons. So it's a butt. And it's all single bonded. Even here, you'll see that it is single bonded. So that means here I'm going to have AN. However, it has a functional group here of a ketone. And that would mean that we'll put the 1 here, ONE. And that's where the name butanone comes from. So this is another name in which one can call it. It's either it can be named as methyl, ethyl ketone, or you can say it's a butanone. So that is the compound D for this answer, for this question here. .3.3. The answer is D. And again, this should be for 1 minute, 1 mark. Now, if we move along and we go to another set of questions, 2.4, they say write down the IUPAC name of the compound. Under 2.4.1, it's A. So we'll begin by that. 2.4.1, we are looking at A. We want to name compound A. Already we figured that compound A is a carboxylic acid. So already we know how the name should end. It should have ionic acid at the end. But now, when we want to name such a molecule, we begin first by looking at the parent chain. That is to say that we look for the long continuous chain. So I'm going to compare all these chains that are here. If I say here I have carbon 1, 2, 3, 4, 5, it means from here to here I have 5 carbons. Then I'll look at the other path and see how many carbons do I have. If I say here I have 1, 2, 3, 4, 5, 6, then this path gives me 6 carbons. But if I say here I have 1, 2, 3, 4, 5, 6, this path here gives me 6 carbon atoms. And of course, this is the one that has the functional group. So it means I'm going to take this as my longest continuous chain, because here I only have 5, and this side here I have 6. However, our functional group is on this side. Remember, the carboxylic acid will always be at the end of the molecule. So we're going to have to count along this line as our longest continuous chain. And the reason for that, because the functional group is at the end, it means we are always going to count from the side that is closest to the functional group. And in this case, our carboxylic acid is always at the end. So it means we're going to count our carbons from this side. So that would mean that now this will be my carbon 1, this will be my carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Then at this stage, I can then now build up my name. We will treat here the methyl groups CH3 and CH3 here as branch chains. That would mean that I will say on carbon 2 and carbon 3, I have methyl groups. So my name will start with exactly that. I'll start by numbering them to say on carbon 2 and carbon 3, I have methyl groups. And because I have 2 methyl groups, you know here, this is the first methyl group, this is the second methyl group. There's 2 of them. It means I'm going to say dimethyl. The di here means that I have two methyls. One is occurring at carbon number 2 and the other one is occurring at carbon number 3. And from here, I'm going to then attach the parent chain. And my parent chain, we can see that it is actually a hexane because we have 6 carbons here. So it's going to be a hexane. So I'm going to say here that we have a hex. But remember, we are dealing with a carboxylic acid. The functional group here is a carboxylic acid. So it means our suffix, our name should end with anoic acid. So here we're going to have anoic acid. So our full name here would be 2,3-dimethyl hexanoic acid. I hope that makes sense. And all this will really cost us 3 marks because we are going to be awarded for mentioning the 2 methyl groups and putting together the functional group and the parent name hexanoic acid together there. Now the next question requires us to name compound B. So we are done with A and then now we are requested to name compound B. So this would be 2.4.2. If we look at compound B here, again, we're going to apply the same principles. When I look at this compound, I can see that it is actually a haloalkane. Why? Because I can see that we have one of the halogens, which in this case is a fluorine. So here we are going to count the longest chain again. So if I look at this carbon, it's going to be 1, 2, 3, 4. So this path here gives me 4 carbons. If I say 1, 2, 3, 4, 5, this path here gives me 5 carbons. Alternatively, I can say 1, 2, 3, 4, 5, and I treat this as a branch chain. That means this path here, it will give me 5 again. Now, because I have 2 parts, this one and this one here, that gives me 5 carbon chains in the parent chain. I can choose any one of them. They will give me the correct name. For simplicity, I'll simply just stick with this one here. I'll take all these carbons to be 5 here. And again, because we have a halogen here, it will take precedence. In other words, we are going to count from the side that is closest to the halogen. I know that we have the methyl groups here. Even here, this is going to be a methyl group. But we will start from the side that is closest to the halogen because the halogen will be superior to the methyl, to the alkyl groups. Now that means here I'm going to count my carbons from this side to say this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5. Remember, I'm treating this as a branch chain. You can also try to name this using this as the main chain and taking this as a branch chain. Compare the name that you get with the one that I'm going to get and see if we get the same name. Now, after naming my parent chain, which is the longest continuous chain, I then now put my name together. We know that we have heptane as the parent chain because we have 5 carbon atoms. But we are going to start with the halogen. We're going to say at carbon 1, we have a fluorine. So that means here I'm going to say 1 fluoro. And I'm going to put a dash again here because now I want to count my alkyl groups. So at carbon 3 here and also at carbon 4, I have an alkyl group. Remember, I'm treating this as a branch and also this is a branch. So this means here now I'm going to have (3-4) to say at carbon 3 and carbon 4, I have methyl groups. But again, just like the previous question, there's 2 of them. That means I'm going to say di because there are 2 methyl groups. And then I'm going to say here is a dimethyl, but this thing is a heptane. This has to be a heptane because there are 5 carbons in the main chain or in the parent chain. And that should be our full name. And again, this name will be 1 mark for identifying each of the alkyl group and also the halogens, and then putting their parent name and only all the name together. Now to go to the next question, which is 2.5, we are told here that 2 distinct organic compounds in the above table are positional isomers. So here we're having 2 different organic compounds that are on the table, and they say those 2 compounds are positional isomers to each other. Now the first question really says to us here that define the term positional isomer. Okay, so let's define this before we can go look for those positional isomers. So we have 2.5, 2.5.1. A positional isomer is an organic molecule or compound, if you like, with the same molecular formula but different positions of the side chain, or it could be substituents. Sometimes it's not side chains, but it is substituents, or sometimes it's functional groups. On the parent chain. Now let me navigate this answer and go through it and see if everything is okay. We're saying here that positional isomers are organic molecules, right? So these are organic molecules with the same molecular formula. So those molecules will have the same molecular formula, but different positions of the side chains. So here there should be an S, subchains or substituents or functional groups on the parent chain. So we're basically moving either a side chain, a substituent, or a functional group in that molecule. Then we call that a positional isomer. Now, when we look at our diagram here, what strikes me quickly is that I can see a fluorine if I look at molecule E, and here also I have a fluorine in molecule B. I mean, if you look at these other ones, you can go through them, you will see that they really don't relate. I mean, this is an alcohol, it doesn't relate with anything else. There's no any other alcohol here. There's no any other ketone in the diagram. And if we look at this, it says cook, and we'll talk a bit about that, you know. I'll give you a hint again in terms of how to remember that or to see that. And you know, this is an alkane, there's no any other alkane. So these 2 for me, I suspect that they're the ones that are isomers. And so to work with them, the first thing that I'm going to do is to determine their molecular formula. So to determine the molecular formula really is to count my atoms and see how many atoms do I have in this molecule. When we do that, we'll start with the carbons. I have 1 here, 2, 3, 4, 5, 6, 7 carbon atoms. So we have 7 carbon atoms. And I'm going to then count my hydrogens. I have a 3, I have a 5, I have a 1, it's a 6, that's a 9, 12, and 15. So that means I have 15 hydrogen atoms, and of course, there is a fluorine there. Now, if we do the same for this one, I have 1, 2, 3, 4, 5, 6, 7 here. So I have 7 carbon atoms. And again, if you look at my hydrogens, I have 3, 6, 9, 12, 15. I also have here 15 hydrogen atoms. And my fluorine, of course, there's only 1 of it there. So if you check the molecular formula of these 2, it's exactly the same. But what differs is the position of the fluorine, our halogen. The halogen here is at the end of the molecule, but when you look at it here, it has actually moved from here to somewhere in that part there. It's like on that molecule is here, and on this molecule it has moved there. So the position of our halogen has moved. And remember, a halogen is part of a substituent. Is part of a substituent, so it falls within that definition. It means for question 2.5.2, the letters that we should write down that represent positional isomers would really be the B and the E. And this should be all for 1 mark. Now the last bit of the question, which is 2.6, says to us here, compound A reacts with compound C to form compound F. So we are having here compound A which reacts with compound C, and they form compound F by an acid catalyzed condensation. So this means that these two, they react in the presence of heat, and they put a catalyst in there that will speed up the reaction, and we form the compound C. Now let us look at our compounds. If we go to compound A, we know that it's a carboxylic acid. So what we are doing here really is that we are taking a carboxylic acid and we are adding that to it compound C, which is an alcohol. Remember, we said compound C is an alcohol. So we're adding here an alcohol, and we say that this should give us compound F. And if we look at compound F, as I said that I'll come to this, we can see here that we have a functional group of COOC, which I can pronounce as cook. Now, always when I see this type of functional group, I always remember the following way of remembering it. Let me write it here. I say ester cooks food that have a pleasant smell. You know, the esters have a pleasant aroma. So when I see the word cook, for me it goes hand in hand with COOC for the functional group of esters. It means this molecule here is an ester because it is made up of that cook. Now we are saying here now, if I go back to my reaction, I'm actually having a carboxylic acid plus alcohol, and it gives me here an ester. And when we look at this reaction and we remember our reactions, we know that a reaction that involves the carboxylic acid, alcohol, and giving me an ester must be an esterization reaction. Is a reaction in which we use to form esters, and usually this reaction will also release some form of water, H2O, because this reaction will involve the substitution here of the alcohol with an alkyl group when the two react, and one will form an ester and the other one here will release the water. And this reaction actually also occurs under the presence of a strong acid which we call sulfuric acid, H2SO4. So that is basically what is happening here if I were to write everything in full. Now if you have time and you take this reaction and write it in full and you add it to this and you put here the catalyst, then if you then break the bonds here, you break the bonds here such that you take the hydrogen here and you take also the OH here, you will be able to form water, and the molecule that will also form there from these two will really be an ester. You can try it and see and practice, these reactions, because it's important for you to also be able to see these reactions. But for purposes of this question, this structure alone here, based on what we were given there, where they said that we're taking A and we're adding C, we should get here an ester and there will be water released. So that's what's basically happening here. Let's see if we can answer these questions from this analysis. Now, the first question here says, write down the name or the molecular formula of the other product released in this reaction. Guys, this should be easy for us because already we have broken this down when I was explaining here. We can see that we'll have an ester and the other reaction. Remember, this one here we are given, it is actually molecule F on the table here. We know this one is molecule F. So the question is asking us about the other molecule that gets released. The other molecule that gets released there is water. You can either say water or you can say H2O. Any of these will give you 1 mark. The next question then says to us here that write down the name or molecular formula of the catalyst. Again, I've spoken about this. We know that this reaction will involve the use of sulfuric acid, or you can write this in full to say this is sulfuric acid. Again, any of these will give you 1 mark there. Then the last question says to us here that write down the structural formula of the functional group of the compound F. Now remember, compound F, I just said here that you will see it by the COOC, which spells cook. And we say ester cooks food that has a pleasant smell. Or you can say ester cooks delicious food, right? The cook here goes with the CEOO. And now we're requested to actually write this structure here, the structural formula of that, and to expand that one and write it as a structural formula. It is given by CO, and then we have an O here. So you can leave it at this, or another way in which one can write it really is to say we have the COO, and then here we have an R, we have an O, and then we have an R. Remember, the R will stand for other carbon molecules or alkyl groups that are attached to it. And normally they're the ones which will have the C, and you'll have the COOC, So here there's a bond here, because also here, so with this structure, we don't include these ones, but it will still be correct, really. Then another way of writing this, you can actually say it is a COO, and we have a C, we have an O, then we have a C here. And that also should give you a mark. Any of these structures will give you 1 mark.